Carlos. Okay, let's go over 21 through 25. Why not? We got time today, so. Okay, so 21. Wow, that looks terrible. What do you not like about 21? Like, be specific. It's ugly, it's long, it's hard. The fractions. So, fractions in fractions. What'd you say, Kinley? So, there's a couple options here. One of the options is keep, change, flip. The trouble is that you really only want to do keep, change, flip. You really only want to do keep, change, flip if you have one fraction over another fraction. So, that's not really a good option right now.
Minus one. Take away the one or no?
It's just like get rid of it. Like,
subtract it.
how about we get rid of the fractions? The fractions is what you don't like. So let's multiply the top and the bottom by 2 to cancel the 2's, and then we won't have, well, we'll still have our big fraction, but we won't have fractions in fractions. So that would be 2. What does the second term become? When I do root 2 over 2 times 2, just root 2. Right? That was the point of multiplying by the 2, is to cancel those. So 2 plus root 2 over, and in the bottom, the 2's cancel again, which is why we multiplied by 2. Okay, so we solved part of the issue, the fractions in fractions things. That's not there anymore. Now we're down to square roots, but we know how to fix those. What should I multiply by to fix the square root? Square root of 2. Because now I will have just a 2 in the bottom. The top will be kind of messed up, but that's fine. We've got to fix the denominator here. So 2 root 2 plus, what's root 2 times root 2? 2. And then root 2 times root 2 is 2. Right?
Which could plus 2.
So in the top, I distributed the root 2 to both pieces.
Oh, I see. Okay.
Can I divide 2 into both of those? Yeah, since it'll go into both of them. Or if you want more proof, like you can only divide factors, maybe it would be wiser to factor out the 2. Then it becomes a little more obvious that you can cancel the 2's. And after all of that, root 2 plus 1. Crazy. Thank you. Anything else on 21? 22 is just about how to multiply fractions. Well, we'll have to subtract in a minute, but let's multiply first. So when you multiply fractions, you multiply across. What's root 2 times root 3? Root 6. And what's 2 times 2? 4. So that wasn't bad. And then the other one, root 2 times 1 would be root 2. 2 times 2 is still 4. In order to subtract fractions, I need a common denominator. We already have a common denominator of 4. So I can just do negative root 6 minus root 2. And I can't subtract those. How about 23? These are getting easier as we go here. Well, so the 4's would cancel. That's one way to say it. If you want to sort of prove to yourself that that's okay, we could factor out the 4. And then it's really clear that the 4's will cancel. And I'm left with 1 minus root 2. Now, hopefully most of you could bypass that and be like, oh yeah, 4 will divide into both of those, so let's do that. I'm not even sure why 25 is on here, because I can't do anything with that. Like, that's okay. Leave it as is. I suppose you could split it up, put them both over x squared, and then you could reduce the first one. But I don't know why that's any better than just leaving it as is. The main thing is you can't reduce that x and x squared unless you split it up first. So that's kind of a weird one. All right, 27. What do you want to do on 27? It's one of those fractions and fractions things. So let's multiply the top and bottom by 3. I'm going to press pause and let you do that. All right, now we got a square root in the bottom. Do you remember what we multiply by to fix a square root that looks like that? Well, the official name is the conjugate, but I bet you were going to say the multiply by the right thing. So what am I going to multiply by? 3 plus root 3. So it's not the inverse. I know what you mean. You're changing the sign, but officially it's called a conjugate. And when we multiply by a conjugate, that should fix that square root, because the O and the I of FOIL will always cancel each other out. So when I do this, I like to do the denominator first to make sure I did this right, because the square root should go away. The top will be uglier, but that's fine. I need the bottom to be cleaned up. So first is 9. Actually, let me press pause again. Okay, so there's that denominator. First, outside, inside, last. What happens with the O and the I terms? They cancel out. That always happens when you multiply by a conjugate. That's why we multiply by a conjugate, to make that square root stuff get cleaned up. So 9 minus 3 is 6. The top is the same process, still a FOIL problem. It's probably not going to clean up as nice because they're not conjugates, but it's still FOIL, so let's see what we get. I'm going to keep things nice and lined up here. So first, 3 times 3. Outside is 3 root 3. Inside is 3 root 3. And then last is plus 3. Okay, yeah, those are not canceling, but that's okay. We only expect conjugate pairs to cancel, so that did not cancel. Cancel in the bottom, not in the top. So 12 plus 6 root 3. Can I divide 6 into both of those? So we can do that. Yeah, or if you want to factor out the 6, you can, but I can just divide 6 into both pieces. So 2 plus root 3. Yes, let's just throw out 26 and 28. Let's see. 29 is just keep, change, flip. Pi over 4 divided by 2. 31 is, do you know how to multiply fractions? Why don't you try, and we'll move on after this, try 30 and 32. We've done one kind of like those already. So, again, throw out 26 and 28, and then try 30 and 32. Then we'll move on. 32, again, if you know how to multiply fractions, root 6 over 4 minus root 2 over 4. That's nice. They already have a common denominator, so just root 6 minus root 2 over 4. Fractionals. What about 33? How would we get a common denominator for 33? What would our common denominator be? Maybe that's a better 12. So that one needs a 4. Second one needs a 3. So 4 twelfths plus 3 twelfths is 7 twelfths. But that's just basic fraction stuff. Not everybody knows basic fraction stuff, but that's basic fraction stuff.
What is
29? Well, I kind of marked over that. That's pi over 4 divided by 2. So, let's see. I would just keep change flip on that. Pi over 4 times 1 over 2. Keep it, change it, flip it. So that's pi over 8.
Can you tell us that, like, pi over 4?
That's a fair question. Why? How do you know that's not pi over 4 over 2?
Yeah.
Yeah, that's a fair question, and I don't guess you'd. I think you have to take it in order. Pi divided by 4 divided by 2. But you're right. If they'd have put like 4 halves in parentheses there, yeah. 33, 7 pi over 12. Which one? 33? So 33, all you're doing is adding 1/3 and 1/4. Right? I mean, we don't have time to how to add fractions. Like we assume you start with some knowledge of fractions. Okay, let's move on.